You think rivers are safe. Think again. A shark leaves the sea and follows warm water inland, slipping into places where people relax, unaware of the predator closing the distance. This is the bull shark, a creature that refuses the ocean's limits. It treks upriver, where you feel safe, guided by scent and heat, indifferent to boundaries humans trust. Our question drives the story. How does a sea predator become river-capable, following warm water inland into the spots we call refuge and safety? Across coasts and estuaries, the bull shark defies expectations. Today, we'll pry open its biology, its senses, and the brutal logic that brings it into our rivers. Expect anatomy like a weapon, nerves tuned to electricity and smell, and behaviors honed to exploit warm currents. This is not a mistake of nature, it's adaptation. We will answer the core mystery. Why follow warm water inland? The answer lies in physiology, opportunity, and a cold efficiency that treats rivers as hunting grounds. Meet the animal by name, the bull shark, common, brutal, and visibly ordinary, until you learn how it moves between salt and fresh with deadly ease. Scientific authority matters here. Its scientific name is Carcharhinus leucas, a predator whose physiology reads like an engineering manual for survival in changing waters. From mangrove mouths to muddy rivers, bull sharks slip upriver, following warm water. They track thermal corridors, a behavior that turns human calm into risk. We begin at the edge, where salt meets fresh. There, the bull shark transforms. Osmoregulation shifts, senses sharpen, and the hunt becomes a private invasion of inland waters. First, the skeleton and musculature. Powerful pectoral muscles and a robust body let bulls push through currents and debris, making rivers another highway for movement. Their skin is rough, dermal denticles like tiny teeth that reduce drag and protect against abrasive river bottoms and entangling vegetation. The jaws are the instrument of finality. Wide, blunt snout, teeth shaped for slicing flesh and crushing bone. The bull shark doesn't need finesse to end a life. Inside that head is a nervous system optimized for three things: detecting prey, orienting quickly, and making split-second decisions under cloudy water. Electroreception is crucial. Ampullae of Lorenzini read the faintest electric fields, a heartbeat, a struggling fish, even when sight fails in turbid river water. Smell is another compass. Bull sharks can detect tiny concentrations of blood and exhaled chemicals, following plumes upriver like a heat-seeking missile. Their kidneys and gills shift function. In fresh water, they reduce salt loss, reabsorb ions, and flush excess water, a physiological trick that few sharks manage. This osmoregulatory flexibility, part kidney, part molecular alchemy, lets Carcharhinus leucas tolerate brackish and fresh water for extended periods. Their cardiovascular system supports sudden bursts. Strong hearts and a streamlined blood flow deliver oxygen to muscles for bursts of speed in confined waters. Vision adapts to dim, brown rivers. Pupils constrict and expand to catch movement, while contrast sensitivity helps them find prey against silt and shadow. Their lateral line senses pressure changes along the body, detecting ripples from struggling animals or the wake of a boat, even when other senses fail. Teeth replace continuously. If one breaks on rock or bone during a river strike, another takes its place within weeks, an endless arsenal for relentless feeding. Their digestive system tolerates diverse diets: shellfish, fish, mammals. Bulls can handle tougher prey, their stomach acids dissolving bone and exoskeleton alike. Heat plays a role. Bull sharks prefer warm water because metabolism and sensory systems perform better, turning thermal corridors into highways of opportunity. Juveniles show different proportions, larger heads, stockier bodies. Those features aid survival in shallow, warm nurseries deep inside estuaries and rivers. Muscle fiber composition balances endurance and sprinting. That mix allows slow cruising upriver or explosive lunges when prey appears at close range. Salt glands aren't the answer. Instead, kidneys and gills change function. It's a rare physiological toolkit that enables long excursions into fresh water. Hormonal shifts accompany habitat change. Cortisol and related systems adjust salt balance and behavior, making upriver migration possible and adaptive. All these traits converge to answer our question. Warm rivers are exploitable environments, and bull sharks possess the hardware to follow that resource inland. But hardware alone doesn't explain timing. Seasonal floods and warm discharges open thermal paths. The shark's senses detect the invisible trail and pursue. Young bulls imprint on estuarine environments. Early exposure to brackish water primes kidneys and behavior, making upriver movements part of a lifetime pattern. Genetics underlies tolerance levels. Populations that regularly enter rivers show alleles favoring osmoregulation, evolution in the direction of freshwater resilience. When you feel safe in a warm, shallow river, remember that thermal comfort is precisely what draws a predator designed to exploit it. We covered tools and tolerance. Now watch how the bull shark uses them, stalking murky water, striking with a violence shaped by confined spaces. The next chapters show behavior and hunting strategies that turn physiological gifts into lethal outcomes for prey and occasional human victims. Bull sharks are ambush predators in rivers. They use low visibility to their advantage, approaching silently and striking where escape routes are limited. They hunt at dawn and dusk when light is low and thermal gradients are strongest. Warm water layers concentrate prey, and bulls exploit that concentration. In shallow channels, they corner fish and mammals, using their bulk to block exits. Pressure from a single body can force prey toward the bite. They investigate disturbances, boats, splashes, noise, because these often indicate injured or disoriented animals. To a bull shark, commotion signals opportunity. Feeding strategy is brutal. Seize, shake, and tear. In rivers, where space is tight, bulls rely on raw force rather than prolonged chases. They scavenge too. Carcasses, fishing bycatch, even waste funnels into rivers, creating predictable food patches that bulls return to again and again. Some bulls patrol territories. They learn river layouts, memory that helps them intercept migrating fish or follow tidal pulses inland. They exploit human activity. Warm water discharges from industry, shrimp farms, and boat wakes create corridors. Bulls learn to follow into populated areas. Adaptability is key. In rivers, bulls alter hunting posture, using slower swimming and sudden sprints, conserving energy while maximizing strike success. Their bite force is substantial for size, enabling them to take down robust prey like turtles and small mammals swimming across channels. They also prey on fish species that migrate upriver to spawn. Those seasonal shocks of abundance turn rivers into temporary feeding festivals. The bull shark's boldness stands out. It will approach boats and people with curiosity and, if tempted, aggression, an unsettling trait for a top predator. They use currents to ambush. Positioning downstream of prey conserves energy and converts turbulence into an invisible net that guides victims toward the attack. Juveniles behave differently. They hide in mangroves and river shallows, using structure for protection while learning to hunt in turbid water. Adults sometimes enter freshwater to escape competition or parasites found offshore, using rivers as both refuge and feeding ground depending on need. They can traverse dozens or hundreds of kilometers upriver. Not casual wanderers, but purposeful migrants, following thermal and olfactory cues inland. When prey is scarce, bulls widen their diet. Crustaceans, birds, livestock near rivers, demonstrating opportunism that thrives where others would starve. They respond to human alterations of rivers. Damming, pollution, and warming can create ideal conditions for bulls to penetrate further inland. Their timing is cunning. Bulls often enter at night when fishermen are active and visibility is low, converting human routines into hunting advantages. Aggression varies. Some individuals are notoriously bold, approaching unperturbed, while others remain elusive, preferring the cover of silty channels. Tagging studies show whales of rivers, repeated visitation patterns, fidelity to certain stretches, and movement that mirrors seasonal prey pulses. They navigate by scent trails that persist in warm water. Chemical cues from spawning fish or decaying matter act like a beacon, drawing them inland. When a bull strikes, it uses momentum and head shakes to incapacitate prey, sometimes abandoning wounded targets to return later and finish the meal. The result is unpredictable violence in familiar places. Rivers become stages where a sea predator exploits human assumptions about safety. We've seen the tactics. Now, let's examine social life, or the lack of it, and how solitude or brief encounters shape the bull's strategy. Bull sharks are largely solitary. They may aggregate where food is abundant, but cooperation is rare. Survival favors individual stealth and opportunism. When they meet, interactions can be aggressive. Dominance is asserted through posture, threats, and sometimes bites, even between adults of similar size. Juveniles form loose nurseries in protected shallows. Those aggregations are fragile. Concentrated prey and protection come with high risk from predators and humans. Competition in rivers intensifies. Food is patchy and dense. Fights break out quickly when two bulls converge on the same carcass or schooling mass. Territorial displays are subtle. Posturing near channels, circling, low bursts of teeth exposure. Mostly, they avoid costly conflict through intimidation. Occasionally, bulls show curiosity toward humans. That curiosity can escalate if a bite yields a reward, reinforcing risky behavior through learning. In the rare social moments, scent and sound communicate reproductive readiness. Males locate females by following chemical cues in warm coastal and estuarine waters. Aggressive mating rituals follow, involving biting and restraint. These brutal encounters echo the shark's broader strategy: force and persistence where subtlety fails. Group dynamics are opportunistic. When a river pulse brings abundance, dozens of individuals may converge briefly, then scatter once the patch collapses. Human presence reshapes interactions. Fishing, noise, and habitat change alter where bulls tolerate crowds and where they exploit the chaos created by people. Loners have advantages in rivers: reduced detection, flexible movement, and less competition for limited prey in confined waterways. Yet social learning occurs. Young bulls observe elders and human-related food sources, acquiring behaviors that increase survival and danger, for both sides. The takeaway: bull sharks are primarily solitary opportunists whose brief sociality centers on feeding and reproduction, not long-term bonds. Now we move to reproduction and life cycle, where brutality appears in birth, competition, and the desperate calculus of survival. Understanding their life cycle explains why rivers matter: nurseries, safe havens, and feeding grounds that shape population dynamics across generations. Bull sharks are viviparous. Embryos develop inside the mother and are born live, already capable of independent swimming and immediate exposure to danger. Gestation lasts around 10 to 11 months. Females time births for warm seasons, releasing pups into estuaries and river mouths where food and shelter exist. Litter sizes vary from a handful to more than a dozen. Each pup faces predation, disease, and starvation from the moment it breathes river water. Nurseries in mangroves and shallow channels act as cradles. But cradles are violent. Predators lurk, and siblings sometimes compete fiercely for limited prey. Females sometimes migrate upriver to give birth, seeking warm, low predator waters. That strategy increases pup survival, but exposes mothers to human risks. Juvenile mortality is high. Few pups reach adulthood, which demands rapid growth, learned hunting skills, and avoidance of both predators and people. Sexual maturity arrives slowly, several years in. That delay makes populations vulnerable to heavy fishing and habitat loss that remove breeding adults. Males compete for access to females. Bites and holds during mating leave scars, a testament to reproduction's raw, physical nature among bulls. Some populations show philopatry, returning to the same nursery areas. That fidelity links river health directly to the species' long-term persistence. In short, rivers are not only hunting grounds but cradles of life. This dual role explains why bull sharks follow warm water inland, generation after generation. As apex predators, bull sharks regulate fish populations and remove weak individuals, shaping river and estuarine communities in subtle but profound ways. By preying on migratory fish, bulls influence spawning success and nutrient transfer between ecosystems, connecting the sea with freshwater food webs. Their scavenging cleanse rivers of carrion, accelerating decomposition and recycling nutrients. This grim service stabilizes the ecological balance. If bull sharks decline, prey populations may boom, triggering cascading effects. Algal blooms altered fish communities and a less resilient river system. Conversely, an increase in bull presence, driven by warming or human changes, can intensify predation pressure, displacing species and altering human use of waterways. They are ecological connectors. Movement between marine and freshwater realms means their fate is tied to coastal management and inland river health alike. Understanding their role helps us see why humans encounter them. Habitat alteration, warming, and nutrient runoff reshape where bulls find food and nurseries. Bull sharks thus become indicators of ecosystem change. Their presence upriver warns of warming waters and disrupted ecological boundaries. Managing rivers means managing the conditions that attract bulls. Thermal pollution, overfishing, and habitat loss all alter predator-prey dynamics inland. In the end, the bull shark is not an invader, but a consequence, an animal exploiting ecological opportunity created by seasons, rivers, and human impact. We must face ethical questions. do we demonize a predator that follows natural cues into altered habitats or confront the human actions that invite conflict? Culling sharks solves headlines but not root causes, protecting nurseries and reducing thermal pollution. Bulls find rivers attractive in the first place. Their existence forces uncomfortable truths. Our safety is fragile, dependent on ecosystems we alter. The line between sea and river is changing under our watch. We open to question: why follow warm water inland where you feel safe? Now you see the answer: physiology, opportunity, and a brutal adaptation to changing environments. The bull shark, Carcharhinus leucas, is both marvel and warning. Respect the river, mend the damage, and remember, nature's predators follow the patterns we create.